Next, detection and response at Planet Scale. Travis Lanham is a Uber tech lead of security operations at Google Cloud, overseeing the technical strategy and direction of teams working on exabyte scale security detection and response. He previously worked in Google's network infrastructure engineering team. Welcome, Travis.
You need a dongle?
Actually, yeah, that would be good. Thank you.
Great. Thanks so much. So today, I wanted to talk about how we're kind of approaching the security operations program and what we do and how we build towards our goal of detecting threats before they can impact our users and our customers. And so our team works on building the platform that our analysts use to protect those users and customers. And so how we've approached this is really thinking of security as a big data problem and saying, even if you have endpoint controls, network controls, identity controls, that you really need this kind of global layer of visibility over everything. And for that, you want to kind of break your data into one place, use analysis over that data to inform controls that happen at the control point itself, and then do preventive measures. And so this kind of complements the approach that we take on things like BeyondCorp or our Zero Trust solution, where we say we want to be able to prevent attacks before they happen, but when they do, we want to be able to detect them quickly, and we want to be able to use that to inform our prevention. And so for that, we start with kind of bringing this planet scale visibility into the threat picture, cultivating threat intelligence from many different sources, gathering data from all the different monitoring sources that we have available to us, and then applying that to do detection at a very large scale, to be able to kind of say, hey, let's take as broad a cut of this data as possible, let's surface up all the things that could possibly be issues, and then really relentlessly funnel that down or filter that down, aggregate it, cluster it into things that are useful for human analysts to take up and go investigate, and get us to a point where we can say, this is actually something that can be a meaningful case, can be something that goes and is worked with a workload owner to get to a resolution on. And then taking all those detections, that analysis we have, providing this kind of risk or context lens on top of that to inform the prioritization of those cases. And then when they're resolved, using that as a mechanism of having continuous improvement in the system, right? So saying, we don't just want to continue to have the same issues come up over and over again. We want to use when an issue happens to inform how should the detection posture of the system change, how should the monitoring change, and then make those adjustments or make corresponding governance and risk adjustments as well. And so for us, this kind of starts at this bottom of the stack, or taking in all this visibility and then organizing it and making that useful. And so for that, we start with kind of all these different places that we can collect network telemetry from all the hosts that we have, additional data sources, and then the visibility we have, particularly on the threat landscape, that comes from things like Gmail mailboxes, safe browsing, which scans all the Chrome URLs, all the visibility that we have into Google Drive files and things like that can be used to protect users and more. And so all of that threat intel gets kind of put into a picture and then joined against all the telemetry that we collect. And the telemetry that we collect comes from many different sources, It comes from production environments, it comes from corporate environments, it comes from all different modalities of endpoint, network, identity, vuln data, context data. We put a particular focus on bringing sources into the system that aren't normally brought into SIM systems or security analytics systems. So in addition to getting really voluminous telemetry sources like firewall logs, sectionized network flow logs, we also focus on bringing in context so that we can kind of take all of that data, structure it, and then use it to build this map of the environment or build this kind of representation of all the entities in the environment. And in order to do that, we bring that context data from sources like CMDB, vulnerability scanners, and then the runtime information inferred from the logs themselves, right? Taking all the DHCP logs and stitching together sessions that allow us to say, hey, here is the representation of a host name that corresponds to this IP address, that corresponds to this MAC address, being able to do that whenever new data comes into the system. So if we have late arriving DHCP logs or out of order logs or different context data that comes in at different times from different sources, we can bring all of that together to stitch together unified representations of the assets, the users, and the resources in the system. And then that allows us to enrich all of those logs with kind of that full spectrum of visibility so that we could say, we start with a simple firewall log that might have an IP address in it. And we can now build out this much richer picture of here's the host, here's who owns that host, here's kind of the full set of context that you would want to be able to do an effective investigation around this entity. And then with that, we start building detection. So we say, once we have that kind of primary source of data, we've taken in all of those logs, we've structured that so that we can enrich it, we've done that enrichment, we now kind of take that visibility we have in the threat landscape and we join it against all the data that we process. And what that gets us is this kind of nice picture of a first level of detection in the system, right? Or this kind of initial, relatively low fidelity, but really interesting kind of picture of what's going on, are there potential attack vectors in the system, what might be happening, and it gets us to this point of going from trillions of events to kind of billions of these low fidelity signals that we can have, right? And so for each kind of set of threat intelligence that we pull into the system, we start with a threat report, we'll pull indicators out of that threat report, we'll expand those indicators, so going from just the original IPs, domains, file hashes, into collections that we can get from sources like VirusTotal, where we have, hey, here's a file hash and here's a set of related hashes to that, right? Or it might even be that it's something that we don't have an explicit relationship against yet, but we can infer from different metadata attributes about the binaries or additional kind of secondary attributes that we have, who is registration, and things like that. So we start with that kind of, let's scan the data for that first set of primary indicators, and then we scan the data for this kind of secondary or expanded set of indicators. Using things like, hey, we want to see what things aren't just implicated in the attacks that we know about, but here are the things that surround them or have shared attributes that we can provide kind of additional, oh, this might not be something that folks know about yet, but this is something that folks should be aware of, right? So we start with primary indicators, secondary indicators, and then we overlay behavioral TTPs that our threat researchers develop to also scan and surface up things that might not be left as kind of evidence of an attack or dug up during forensics, but are things that are helping us expand this picture, kind of capture a broader net of activity that can then be investigated. And so from there, we're able to kind of take all of this, scan this retroactively against the data. For things like the behavioral scanning, we do this in a batch mode, so it might not be instantaneous, but we can kind of chew through all the data that we have in the system and get that kind of compiled automated compromise assessment that then can be handed off to an analyst to go work. And so there we're able to kind of now take this, that raw intel that we have in the system and package it up into something that's a bit more fully finished that analysts can go and actually engage with. And now we've been able to capture not only those kind of simple indicators, but now these kind of more behavioral type detections as well, right? Whether they be from those inferred indicators, whether they also be from things that we infer from metrics, like, hey, here's a low prevalence binary talking to a low prevalence domain, right? So we can now alert on these kind of behavioral signals or broader signals rather than having explicit indicators that we have to match against. And then for here, what we say is, okay, we take all of that threat intel, we index it against our logs so that we can provide really fast investigative search for analysts. And that kind of comes in two forms, right? One form is anytime someone goes and wants to look up an IP address or look up a domain or look up an asset or a user, we want that search to be as fast as possible. We'll cache events, we'll go and kind of rank and score events that come through the system so that we'll say, hey, these logs are actually more interesting because they're for low prevalence IP addresses, right? Or these logs are more interesting because they're file hashes that we correlate against threat intel. And so we'll provide this index search against the logs with that fast retrieval. We'll also provide really kind of powerful analytical queries so that analysts can go and look at metrics in the system so they can see, hey, I'm interested in hosts that have interacted with low prevalence domains and low prevalence domains that have been registered in countries that are on a watch list for us, right? Or on something that we might want to keep closer track of. And then this allows us to kind of build up to that signature-based detection system where we've now said, hey, we take in this broad swath of telemetry, we do this initial kind of threat intel assessment on that telemetry, and now we have another kind of pass of this where we have threat researchers that are constantly putting in different types of detections. These could be tripwire detections where we're looking for things like command line regexes, mutexes, things like that. They could be whatever kind of signature of activity a threat researcher might be interested in. And then we're able to evaluate these against that enriched event stream in real time, and then provide this kind of base finding or kind of this first pass of here's the interesting data that we might want to take a look at. And so when we get to that, it's still way too much for a human analyst to go and look at, right? We've taken in all this data, we've gone and correlated with threat intel, we've got kind of this first pass of detection against it, but it's still something that's nowhere near scalable for humans to go and look at. And so there we kind of have two main techniques that we've built out to support doing that analysis on top of this large volume of findings. One is basically around using metrics and risk as kind of a layer on top of those findings. So rather than looking at individual findings, going and looking at a risk view of the data. So we take all those entities that we inferred from the telemetry or that we ingested explicitly from other sources of truth. We build out this graph of relationships in the enterprise so that we can say, hey, here's all the different entities, here's who's interacting with who, here's how often they're interacting with each other, here's the kind of contextual linkages between them that could come from our permission access management data, that could come from our IAM system data. And now we're able to take that threat view or take that, hey, we've brought in all the logs, we've correlated against threat intel, we have those initial detections, and now we can correlate against this kind of picture of the context. So we can say, hey, we might have something that looks like threat actor activity, it's a beacon to a CNC, it's some other TTP that we have, and we can say, okay, is this exploitable? The machine that this was discovered on, are they running unpatched software? Is this something that an attacker could actually be exploiting right now? Obviously, that'll depend on the TTP on whether it's an indication that it already has been exploited. But if it's something that's more on the bulletin side, or it's something that's just kind of a lower fidelity indicator, this kind of contextual picture allows us to say, hey, we can filter out a lot of stuff that just isn't of interest, right? Whether it be things that are from a development environment for the security team, or somewhere where we expect this kind of activity to be happening. And now we can kind of put focus on the pieces that are most important, right? We've discovered a vulnerability, we've seen some runtime signal that has been exploited, and we know that the impact of that exploitation would actually be significant, right? We can infer from the context that an exploitation of this system would lead to a lateral movement opportunity that would lead to critical data in a database or in a file system that might have user PII, that might have sensitive financial information, that might have other data that we would consider to be high risk, right, or high impact if it was exploited or if it were exfiltrated. And so this gets us to taking those kind of billions of detections or kind of millions of alerts that would come out in the system and being able to prioritize them and be able to say, hey, these are the ones that are most worthy of human attention, are most worthy of being kind of passed into other parts of the system that would then do aggregation if they're not worthy of being looked at immediately at that time, right? So that we could say, hey, there might be certain situations where something should just be looked at immediately, right? This could be something if it's in a production environment, if it would have access to sensitive data, if there would be sensitive admin privileges that would be available for an attacker, and if it's something that's hey, this might be something worth looking at, but it can kind of be batched into something with additional similar alerts or additional kind of similar findings, then that could be grouped together and shipped off to an analyst as a single case. And so that gets us to kind of the other piece of this kind of post-processing element after detection that we've built out in the system, which is basically looking at how can we take those alerts and find linkage between them, and do this in a more automated way than what we previously did, which is around, we started with being able to say, hey, we can just kind of provide simple grouping capabilities to analysts. We can say, we're interested in things that happen on the same host, or we're interested in things that happen to the same user, or we're interested in things that happen with the same artifact, the domain, IP address, et cetera, right? And how can we provide a less heuristic-driven linkage between the alerts? And so for this, we built out a bunch of AI models that allow us to say, hey, we can extract features from those alerts. Things like when they happen, the entities that were impacted, the TPs that might be associated with the detection that generated the alert. We can pull all of those together and now create these kind of clusters or paths of attacker activity in the system, or things that are related from an alerting standpoint. And what this gets us is a much kind of compressed view of everything that we had at that previous detection stage. So now these can be grouped together and shipped over to an analyst where they can say, okay, we now have this kind of broader picture of what was going on around this time. We don't need to be having humans piece together these alerts manually. And we can use the prioritization or kind of context signals to drive that additional ranking or prioritization around this. And so what this gets us to, that we've seen when we applied this to endpoint alerts, for example, is being able to kind of reduce the noise down by a significant factor. And this also allows us to apply additional heuristics on top of the groupings, where we can say things like, okay, if there was a routine maintenance patch that came through and it triggered some tripwire detections, it's now easier for us to say, okay, we now have those kind of grouped together, even though before we might not necessarily have had a grouping rule that was looking at things like, oh, what's the software maintenance window, what's the application that's being deployed that's triggering all of these alerts. And now this is done in a more general way, and now additional heuristics can be added on top of that to say, hey, if we see this kind of all the software on these hosts has changed recently, now we should just mute this, right? Or maybe this kind of goes into a lower priority queue where it can be looked at separately. And so here what we've done is said, okay, we took in that full stream of the logs, that full stream of the telemetry, we've overlaid that kind of threat intel picture on top of it. We've gone and done that first layer of detection, whether that be heuristic-based detection, tripwires, things like that, whether that be more behavioral detection with all the metrics that we've generated in the system, so that we can say, hey, here's, this is the first time this host is interacting with this domain. This is the first time that this, collection of files or executables that are related to each other has been seen in the system, and they're contacting a bunch of IPs that haven't been seen before. And now we're kind of building this into this picture of, okay, we have those detections, we now have this kind of prioritization and this grouping or clustering that we're able to compress those signals down. We're able to provide this kind of ranking input on top of them. And we're able to package this up now as something that's much easier to scale out to a team of human analysts. And now those analysts are not, kind of also empowered with this contextual view, right? Or this, hey, we now know that, we're looking at this alert, and if this was, exploited, here's kind of the impact from a business standpoint. So we're laying on top of, those detections, this business risk kind of view of what's going on. And that allows us to kind of build up to the kind of final point around continuous improvement in the system based on the response activity that we take, right? So we say, based on when we actually get that case off to a human, they'll go and do a variety of things that you would do in instant response, right? It could be contacting the workload owner, it could be doing additional investigation, it could be doing a forensic analysis, on an executable that's involved. It could be this kind of wide variety of things that might happen. But then, no matter what the result of that analysis is, we want to learn from it. We want to improve the system and get it to a state where now that we have that learning, we can either improve the fidelity of the detection monitoring, we can improve the posture or kind of governance that we have, and make sure that that doesn't happen again, and then ensure that there aren't regressions against that. And so here, there's kind of two pieces that we focused on. One is more recent, which is around how can we enable assisted response, or how can we enable our analysts to be more efficient. And then the other is how can we have kind of more of a compliance lens or more of a risk governance lens, and use those kind of findings from continuous improvement to reduce noise in the system in the future. And so on the assisted response side, this is a more recent project that we work on. We've said, how can we go and take large language models like Google's Gemini model and use that to enable a security analyst to do a faster investigation. In particular, we focused on kind of the initial triage phase of the workflow, where we said, how can we connect in all of the data sources that an analyst would typically pull up when they're looking to triage an alert, right? This could be sources from threat intel. These could be sources about asset information. These could be sources about external artifacts, either activity or context. Bring all of those kind of data points together, and then enable an analyst to ask natural language questions. Enable an analyst to get this kind of easier picture, kind of this more complete picture presented to them. And most importantly, this kind of ties into enabling them to see what's historically happened, right? So enabling them to see, hey, here's how similar alerts have been resolved in the past, right? Because one piece is kind of showing them a bunch of information and showing them a bunch of context, but particularly for new analysts on the team, the biggest improvement is showing them what a senior analyst has done with the alert in the past, right? And kind of helping bring this institutional knowledge in the SOC, or this institutional knowledge in the security team, to a new analyst to scale them up and accelerate their ramp into understanding, okay, here's kind of what this environment looks like, right? Or here's how alerts like this should be handled. And so to do this, we take those data sources, we take that foundation model, we fine tune it with the security data, and now we provide that to an analyst to be able to do this assisted response, right? Where now when they're looking at that alert, they have this historical picture of what's happened in the past. They can kind of get contextual information easily, and it's presented to them in a way where they can quickly understand what's going on in the system. They don't need to have a lot of context on which particular place they need to go and pull the data. Although they can always click in, and over time they'll kind of learn those systems in the same way that a more senior analyst would. And then in the future we plan on kind of bringing this to other parts of that workflow, right? So kind of starting with triage, because it's one of these simpler parts where it's mainly about bringing a bunch of information together and synthesizing it. And then the next piece being things like scoping the investigation, right? This comes in with things like, here are the similar alerts, or here are kind of the similar signals that you might be interested in when you're looking at this. But it also includes things on, okay, we have an alert on this asset. Here's the other activity that was happening on this asset at this time. And based on that other activity, we might be interested now in, okay, we were looking at this asset, it contacted this domain. We can now kind of take another step from that domain onto other similar domains. And now we can, provide this kind of scoping activity where we can now say, okay, there might be a connection between that domain and other alerts that are being worked on at this time, right? And so we can pull together all of those different pieces so that we can say, hey, here's kind of the full scope of the investigation. And one analyst might be working on one part of this, another analyst might be working on another part, and how can those different work streams be merged together? How can we provide this kind of context over the SOC or enable analysts to understand what other folks are working on, and bring that all into kind of one picture for everyone to understand? And then increasingly, even further beyond that, how can we think of this as something that we go from assistance into more automation, right? Particularly around things like triage, where now once we have a lot of feedback from analysts, we can now kind of encode that as automated triage that at first could be something like, here's a suggestion on whether this alert should be dismissed or not, and then in the future kind of doing more auto disposition on the alerts. And that kind of gets us into the three kind of pillars we have around continuous improvement, or once we have that response activity encoded in the system, what do we do with it, right? So if it's something like, hey, we've closed this alert as a false positive, we want to ensure that the analyst is empowered to either go and update the monitoring that generated that detection, or is able to pass it on to the detection engineering team as feedback to say, hey, there were false positives around this, this needs to be adjusted in this way, or this wasn't applicable for this particular environment, and here's how we can go and tune those signals so that we can get much richer monitoring in the future, and we can kind of keep this nice yield where we look at a metric around what's the true positive rate that we're getting out of the detections, and what's the wasted work from false positives that we're consuming from analysts, so that we can have a high analyst productivity, not only in an analyst being able to look at a certain number of alerts or look at a certain number of difficult alerts, but being able to have that work be put to good use, right? To be able to have that work be put to productive investigations and not be put into things that don't bear fruit or kind of just false positive based on, this is an instance that someone on the security team set up, and so of course we'd expect there to be some funny behavior going on, but it's not something that's actually a problem. And so that's that kind of first piece on how do we improve the monitoring. The second piece is around how do we turn things that might be true positives or things that we want to look at into better prevention or into better governance, right? And so that gets us to, okay, if we see that there was an account that didn't have two-factor authentication enabled on it, right? How do I identify that, hey, here's this kind of cohort of users where there needs to be kind of governance or compliance poke, or these folks need to go and have someone follow up with them, someone go and ensure that this particular team follows the same kind of set of requirements, et cetera, right? And you kind of get to this, okay, if we had an alert and it wasn't important, we update the monitoring. If we had an alert and it was something of interest, now we need to go and put preventative controls in place. We need to go and look at, okay, here's how we can roll out a compliance, nudge to this part of the organization to go and adjust their behavior, adjust their systems so that this doesn't happen in the future. And then the kind of final pillar in that is being able to say, okay, now that we have those controls in place, right, or now that we have, okay, we're monitoring what the two-factor authentication compliance is for this part of the organization. How do we ensure that we don't have slippage against that, right? Or how do we have this kind of regression prevention? And so there we look at things like, how do we actually go and test our detections regularly so that we trigger the behavior that we want to be monitoring against? How do we go and trigger the behavior that we would want to have governance monitoring or governance control tracking? And so for that we have automated systems that go and have agents that represent or kind of look like a certain part of the system. This could be something that's supposed to act like an endpoint and occasionally detonate something that looks like it's malware to see if it actually gets stopped by an endpoint control. This could be something that's an agent that's going and testing a network boundary to ensure that a firewall is correctly configured and in place. The same for identity, etc. And so that kind of brings us onto the, okay, now we've brought in all this data, we've kind of looked at this broader threat landscape, we've put in all the detections that our researchers are interested in, we've gone and allowed triage over that, and we've gone and prioritized the things that come out over that. We've gone and clustered them together so that they're more consumable for humans to work as cases. Once those cases get to the humans, we've tried to enable them to be more efficient in how they handle them. Once they kind of do that disposition on the case, then we enable the system to improve by either improving the monitoring or improving the governance and compliance around it, and then monitoring against regressions against that. And that's it. Thank you so much. Any questions?
Okay, we have time for one question.
Hi, it looks early on that most of the the data that's feeding the system is well formatted. And then when you were on the SecLM slide, you mentioned that senior analyst historical responses to things would also be part of information to like a junior analyst. Is that well formatted data, or is that coming from a language model, or how do you inject that into your system?
Yes, great question. So there's kind of two parts to that. One part is basically the telemetry itself, and so some of that's very well structured, some of that's not as well structured, and so there's a lot of techniques that we have on ensuring that we get quality structured data out of it, no matter the source. Then all the detections happen, et cetera. And then the what is provided that triage phase can be from two sources. It can be from kind of metric sources on, hey, for these types of alerts, here was the disposition status in the past, here was the criticality status in the past, or it can be more free-form, semi-structured comments or analyst feedback, things that might be go reach out to a workload owner, they respond with a response of, oh, this doesn't matter for this environment, but it's not captured in a structured way. And so that's kind of where the language model has helped on being able to say, okay, now we can provide kind of a more in-depth analysis on some of those less structured pieces.
We can sneak one more in.